My name is Diego Kaminker. I'm from HL7 International, introducing Rostislav Antonov from the Health Samurai. And his presentation is about FHIR native fine-grained access control. Thank you, and you can start.
Yeah, can you hear me? Yes. Okay, so I am Rostislav, a software engineer at 8box FHIR server team at Health Samurai. And yeah, now we're going to talk about FHIR native fine-grained access control. So please raise your hand if you already know something about FHIR security labels. So actually, a lot of guys knows. So for ones who don't know anything, there will be introduction in the beginning, and then we will go into details and trade-offs. So let's start. Healthcare information contains a lot of sensitive data that must be carefully protected. And the key question here is, how do we give healthcare professionals only the data they need to do their work effectively? And our goal is to avoid exposing more data than necessary. So let's take a look at a specific example. Psychiatrists working with the patient must have access to highly sensitive mental health information alongside general healthcare-related data. And psychiatric nurse also may have access to mental health information. But do you want other nurses reading your mental health notes? I don't really think so. And also, general practitioner is here who should see patient vitals, but shouldn't have access to mental health information for various reasons. And this list can be endless and always depends on specific institutional policy. And let's take a look on this business case from FHIR implementer points of view. So I think all of you know observation resource in FHIR. Observations are central elements in the healthcare. And in FHIR, observation is quite generic resource. So heart rate measurement will be stored in observation, and blood pressure and depression assessment as well. So when your application make a GET request to a FHIR server, like to read all observations, depending on who currently is using your application, FHIR server should return different responses. For general practitioner, for example, this observation bundle should not contain depression assessment, but psychiatrists rely on this information. And and also as example, patient resources here, and patient resource contains a lot of information. Some of the patients, in addition to home address, have billing address or mailing address, and they don't want to share home address with everybody. And also social security number is stored in patient resource. And while, for example, clinical biller needs your social security number, others in clinic shouldn't have access to it. So we actually need to hide some resource fields while exposing rest of the resource. It means we should be able to configure our access control not only on the resource level, but on the specific resource field or on the specific resource element level. And the question is, can we achieve such access control granularity? In fact, we not just can do it, but we can do it in FHIR native way. Yeah, and FHIR gives us security labels. It is a tiny but quite powerful concept attached to a resource. Let's imagine this slide in my presentation is our FHIR database. And we can take tags or labels and attach these tags to a resource just right inside the database, but not only the resource, but to a specific field in the resource. And these labels will tell our FHIR server who can see this information. Yeah, as I mentioned on the previous slide, there are two levels of labels. First one is resource level labels. They live on the top of the resource in meta security property. And meta security is an array, so you can attach as many labels as you need. And here is an example of the confidentiality label with the normal level of clearance. And the second level, it is inline or element level labels. To use them, first of all, we need to put process inline label in meta security to let FHIR server knows when inside the resource we have inline security labels, and then we need to attach inline security label using an extension on a specific field. Again, here's the example, and we attach the location sensitivity label to a home address. And security labels in FHIR are code systems, and one of them is the free confidentiality code system, and this one is hierarchical. So it means if I have access to a restricted data, I automatically can see all data with lower level labels. And also we have purpose of use and act code systems. These are flat labels, so no hierarchy here. It means you either have a matching tag and you have an access, or you don't. And yeah, how does it work all together? First of all, we need to attach labels to all the resources in our database, and then give our users certain set of labels, certain sets of access. And when user make a request, our access control layer match the user's labels with the requested resource labels, and with, if they are matched, we give an access on a resource level. And then we need to check, does resource contain process inline label? And if it does, we need to go through each field in the resource, and if user have access to all the fields in the resource, we expose resource as is. But if some of the fields not accessible for the user, we need to replace them with data absent reason extension. So some implementation details in our FHIR server 8 box. When the label-based access control is turned on and requests come to in 8 box, we need to, first of all, we need to collect users' labels. And here we look at two places. First one is JWT access token scope claim. And second, optional, is security label property on the user record. And of course, we need not to forget expand hierarchy, confidentiality hierarchy. So user with the restricted level will not lose access to normal data. And under the hood, 8box uses security FHIR search parameter to apply resource level labels. So for example, the get FHIR observation request with the labels in access token will change under the hood to get FHIR observation request with the security search parameter. And we use Postgres as our database, so we will transform this request to SQL query. And this is very important because at this exact moment, we apply our resource level access control. This SQL query will not return any resources without matching labels. So, and after we get resources from the database, we need to check for process inline label and traverse all the resource tree for inline security labels. And here on the example, we have, like, we had the label, and user does not have access, so we change the value of the property to data absent reason mask extension. And yeah, as you may notice, the labeling enforcement adds processing overhead at several points. So we measured performance. We compared free 8 boxes without labels at all, with labels only on the resource level, and with inline labels. And it appeared we lost a bit more than 7% with inline labels. And I think if our application doesn't really fight for each millisecond of performance, it's not a big problem for you. Yeah, and before we go and talk about the trade-offs and downsides, let's summarize quickly the upsides. So first thing is why we love FHIR: interoperability. The FHIR security labels use HL7 code systems. Second is resource level granularity. So we can attach as many labels as we need to a resource, so we don't need to base our access control layer on a resource type, and at the same time, when somebody requests, for example, all patients' observation, we do not worry that users with lower level of access will see some sensitive data. And last but not least is field level granularity. We basically can hide specific field in the resource while exposing the resource itself. And yeah, let's talk about the problems. So first, but not the biggest problem, is that when the user see in the response data absent reason, and just next to it, a bunch of security labels, user who might be an attacker actually immediately understands what exact level of access we need to get to see this data. So the possible solution we came up in the 8-box, it's strip label flag. So when you turn on this flag, we remove all the labels from the response so user cannot see actual labels on the resource. And another much bigger problem, in my opinion, is that the disclosure of data absence can be data leak itself. So when we return data absent reason extension instead of the real value in the field, we kind of tell the user there is something that you cannot see. And for the stigmatizing information, for example, like mental health information or substance abuse, even knowing data exists can be problematic. And you might say just remove these fields, do not return them at all, like they don't even exist. And here we have another problem. Not revealing data access denials might be interpreted as data does not exist in at all, and that could lead to wrong medical decisions. So here we are skating on the thin ice, and actually I don't know an easy solution for this. It must be, I think, really careful decision for each specific case. And yes, and FHIR required certain fields to be present, and what happens if we mask these fields, if we change the required fields? It means we will return in the response not conformant resource, and while the conformance for the sake of conformance is an acceptable trade-off, maybe the real problem begins if the client application relies on required fields being present. So it's kind of the privacy versus conformance, and sometimes I think privacy has to win. Yeah, let's move to a Postman and see how it works in real life. I need to switch to Postman. So yeah, I prepared a couple of requests to the same FHIR server. Here is the search of observations. I prepared the access token, is JWT access token, and it contains some labels. You can see them here, like confidentiality restricted label and psychiatry information label. So let's make a request. So we have two observations in the FHIR server. Let's switch to a pretty view. So yeah, we have the heart rate observation and PHQ total score. So this is mental health observation. And on the mental health observation, we have two labels, restricted confidentiality label and psychiatry information label. So while this user have both these labels, this user, whom, for example, psychiatrists have access to this information. But let's make the same request to the same FHIR server, but on behalf of user who doesn't have psychiatry information label. So we make a request, and now we see that we have only one observation in the bundle. So let's switch to a pretty view, and here we see only the heart rate. We do not see mental health observation. And another example is the read of patient, of the specific patient. And first user, let's imagine it has the normal confidentiality tag and location sensitivity tag. And when we make a request, we get access to a resource, again, pretty view, and we have two addresses here. The home address that contains the location sensitivity label on it, on the specific field, and the second billing address. So let's make the same request from another user, and this user does not have this location sensitivity tag on him. So we make a request and see that in the address we have the billing address, but the home address is hide, and we see the data absent reason mask extension there. Here's the pretty view, mask extension instead of the home address, and billing address is here. So let's, we saw just this inside the Postman in real life. So and this is the end. I will not repeat myself, just one conclusion from my talk. Labels are sharp tool, but still have a lot of trade-offs you need to consider. And connect me on LinkedIn, and let's move to questions.
Thank you very much. Questions?
Could you clarify who applies the labels?
First of all, you need to attach labels to resources in database, so make this labeling process, and then you need to, in your system, whatever you use for user management, attach some labels to users. And when you make a request, our FHIR server knows the user's labels and knows the labels inside the database on the resources. And
right. So I was okay. Who applies the resource labels? Does the client when they create the resource?
Yes.
Okay.
So the client who uses the FHIR server needs to label all the resources in the first place in database to make this work.
So that implies they need to know all of the policies that are on your system, and that list of policies cannot change once the resource is added to your system.
Yes, I mean, it can be changed. You can demigrate your database and change the labels, but yes.
Okay.
Any other?
Is there a break the glass mechanism implemented as well?
There is break a glass mechanism and break a glass label. I didn't mention it because we didn't have a lot of time, but yeah, here these flat labels is a break the glass label, which allow you to break the rules, but again, you better use auditing or something, just nobody will violate this mechanism.
Thank you. Excellent talk. So I think this is similar to maybe Elliot's question, but so you kind of pointed out the likelihood of patient safety risk for data filtering. I think of it as kind of when you restrict a single med, but otherwise represent your list of medications as the active medication list. That's always going to have a possibility of causing risk. And I know that AidBox is kind of highly configurable, and as you kind of alluded to with Elliot, it's do you have just happen to know how health systems that use AidBox deal with that possible risk when they're using labels like this?
So yeah, as I said, the spec itself, FHIR security spec, does not tell you the exact behavior, so it's always up to implementer. And yeah, I don't have real answer for this. You need to.
I can answer. So to be honest, in real settings, yeah, people are more using auditing than masking stuff. But sometimes it's masking for nurses and otherwise. So it looks complicated, but in real life, real rules are much simpler like this. Yeah, but maybe if we go to portals, then the rules may change. Yeah, so.
We have a question.
Thank you.
Thanks for your talk. So you only talked about read access, you monitor the read access. How about the write access? If I'm an adversarial agent, I would go remove all those labels. I send a write request to remove the label, and then I'll send a read request. Ta-da! I have access now.
Yes, exactly. For now, this does not resolve the read or write and delete operations. So you need to hide this access using different part of your access control layer, using access policy or whatever you use. So yes.
Hi. Do you filter history bundles as well, or do you just hide them from non-administrators?
So again, it depends how did you label your database. If you labeled your... So one thing I maybe didn't mention clearly, if you're in our implementation, if your resource does not contain any labels, it's not accessible at all. So if you will not label the history table, so nobody except, we have kind of the super admin role who can see all the data, doesn't matter what labels that has, but anybody else cannot see any resources that does not have any labels. So.
Hi, would the labels work with consent and consent resources as well?
Yeah, you can put the labels on the consent resource.
No, like if the patient is giving consent.
No, the question is if you are taking into account the consent resource for this.
Yeah, I mean, we do not have any automatical mechanism, automatical model to label resources, so you should do it like itself for now in our implementation.
I think the label, security labels, is a great tool to do consents, like executable. And the idea that we probably can implement, so you just have to put like in a session of the user and the patient these labels which are accessible. And the labels are much better than, let's say, scopes from Smart on FHIR, because you can label different type of resources, but it's up to labeling service. So, and then it's better to make executable consent with the labels, but not vice versa.
Okay, I think we are on time. Thank you very much again.
Thank you.